as we're starting to prep up for our final mastery, to be factor master, I did this little summary kind of thing. Think of it, kind of we'll do it together to get kind of like a cheat sheet kind of thing, okay? All right, so the very first step in question that you should always ask yourself is, do I have a greatest common factor, right? Factor something out, and then how many terms does that work for? Two or more, yeah. I mean, it's basically unlimited, right? It works for anything. And you're undoing your distributive property, so what you're left with is going to be the greatest common factor on the outside, and then the number of terms you started with on the inside. That make sense? Okay. Then the second question you ask yourself is, how many terms does it have? Okay, do you have 2, do you have 3, do you have 4, do you have anything over 4 is always going to be greatest common factor. Okay, for the most part at this point. All right, so grouping. How many terms do you need to do grouping? 4, absolutely. Okay, and what you're doing with grouping is you're breaking it into, so it basically it breaks it into 2 separate greatest common factor problems, right? All right, so if we have, let's say, 3x squared plus 9x plus 2x plus 6, and I break it down and I group it into 2 separate problems, and then I just look at each problem one at a time. So what's my greatest common factor? 3x, I'll agree with that. So that goes on the outside, and what am I left with? X plus 3, I'd agree with that one. All right, now let's look at this other problem. What's the greatest common factor of that one going to be? Yep. And I'm left with x plus 3. Okay, so this was my greatest common factor. This was my greatest common factor. I can regroup those together and then keep the remainder along for the ride. How do you feel about those? Good? Okay. All right, split the middle. How many terms does it work with? 3, right? Okay. And one of the things about splits the middle is that your exponents have to be even. Okay. So for instance, if you have ax squared plus bx plus c, it's always going to break down to your x plus a, x plus b. You're always going to have just the 2 binomials, right? And if you had, let's say, x to the 4th plus bx squared plus c, then it just breaks down into your x squared. Do you agree with that one? Okay. All right. So let's say we have 4x squared plus 12xy plus 9y squared. What's the first step? What's the first thing I want to do? How do I split the middle, though? How do I multiply what? Yep, multiply your a times c. Okay, so a times c, that has a sum of b. So 4 times 9 is going to give me 36. And I want it to equal 12. Now I know it's not 1 and 36. I know it's not 2 and 18. Let's see, 3 and 12. That's not going to work. 4 and 9 is not going to work. Oh, look, 6 and 6. Because 6x plus 6x is going to be 12x. Yes? All right, so let's split that middle into 6xy and 6xy. My first and last terms just kind of come along for the ride. And now I have 4 terms, so I go back to the grouping. All right, so I have 2x as the greatest common factor, which leaves me with 2x plus 3y. Good. And I have a 3y as a factor, which leaves me with 2x plus 3. With me? Am I going too fast? No? Okay. All right, let's regroup those together. 2x plus 3y and 2x plus 3y. Those are the same. I'm multiplying the same thing by each other. What's that also called? A square. So I could rewrite it like that too. Yeah. Oh, I did forget the y, didn't I? I'm sorry. My apologies. Thank you for catching that. Okay. How do you feel about those? Good? Everybody's shaking their head. Awesome. Okay. Difference of squares. What do you know about difference of squares? How many terms? 2. Absolutely. And what do you know? There's 2 like rules to remember. What's one of them? Yep. If both terms are positive, then it's prime. I like that one. Okay. What's the other thing? Both terms must be what? Yeah, that's it. Perfect squares. And the rule is always going to be the same, where if you have x squared minus b squared, you're always going to have x minus b and x plus b. You just take the square root of them, right? So if I had 4x squared minus 9, square root of 4x squared is going to be 2x. Square root of 9 is going to be 3. Boom, done. Feel okay on those? I think the hardest part on those is going, oh, it's a perfect square, especially if it's the bigger numbers. Yeah? Good? All right, last one. Different sum of cubes. How many terms does it have to be? 2. Perfect. Okay? And we have 2 rules. Both terms must be what? Both terms must be cubes. Okay. If they're all cubes, and if they're all there are no primes. Okay. The only time you have that plus thing is if it's a square. All right. And this is the one where we're going to use SOAP. And so if I have a cubed minus b cubed, I'm going to have same sign, opposite sign, and always positive. Do you agree with that? Feel good about those? And then if you have a positive, we just flip all the signs except for our always positive. Feel okay about those? So think about, like this is the single. These two are squares. And the middle is always the multiply. Good? Those are cube roots. Okay, just A. Feel okay about those? Does that help kind of summarize it all together to kind of put in perspective as far as, okay, let's look at the GCF, okay, now let's look at the terms, now let's look at the numbers kind of thing. That help summarize it? Oh, shaking your head yes? All right, awesome.